Hello everyone. In this video we will be talking about tensors and how they transform. So what are tensors? Before answering that question, let's first look at a simple linear transformation. The transformation will be a clockwise rotation of the xy plane by an angle theta. So we can represent our new sets of coordinate by x prime and y prime, and the transformation matrix will be cos theta minus sine theta cosine theta on xy. Now we can simplify this and write equations of x primed and y primed as x cosine theta as y sine theta minus x sine theta plus y cosine theta. Now let's find del x primed over del x. This would turn out to be cosine theta, and del x primed over del y, this would be sine theta. Del y primed over del x, this would be minus sine theta, and del y primed over del y, this would be cosine theta, right? So we can place these partial derivatives into our sets of equation. So this would turn out to be as x prime is equals to x times del x primed over del x, because del x primed over del x is just cosine theta and we had x cosine theta here, plus y into del x primed over del y, and now we have y primed is equals to x times del y primed over del x plus y times del y primed over del y. Now one thing to keep in mind is that any linear transformation can be represented by a linear transformation matrix like this, right? So any linear transformation would result in equations, in sets of equations like this set right here. Okay, so moving on, we can write these sets of equation in a more compact manner by writing it as, let's first define x to be x1, y to be x2. So we can write our equations as x primed of I is equals to sum over j xj del x primed of I over del xj. Notice that if we have, say for x, if we have I is equals to 1, this equation would turn out to be x primed of 1, meaning x1 primed, which is basically x primed, which is equals to this summation right here. Since we have two coordinates, j will be 1 and 2, so this would turn out to be x1 del x primed 1 over del x1 plus x2 del x prime 1 over del x2. So x1 was just x, del x1 primed was just del x primed over del x, plus x2 was y, and del x1 primed was just del x primed over del y, and this equation is just x primed, right? So we have got back to our original equation. So we have compacted these two equation into one single equation, right? Now what Einstein did was he contracted this equation even further. So what he did was he wrote it as x primed I is equals to xj del x primed I over del xj. So what he did was he removed the summation sign and proposed the Einstein summation notation. So basically he just removed this summation sign and made the work a lot easier, because when we will derive the Einstein field equation, there will be lots of tensor equations, and writing summation sign is a very hectic process. So we ignore that summation sign. Alright, so whenever we have a index on the top, the same index on the top and bottom, we will know that there is a summation sign, which we don't usually write. Okay, so moving on. Now what if in terms of this x primed and y primed we had, in terms of this x and y we had a vector, the components of a vector. What if we had the components of a vector in place of this x and y? So after the rotation, the components of that vector will be shifted, right? So if we maintain all of these equations, then for the components of the vector we can write another equation, say a primed alpha is equals to, this is basically the same equation but in terms of the components of the vector. So this would be a I del x primed alpha over del x I, right? So we've written the equation in terms of the component of a vector. Now let's consider another component, say b primed of beta. Sorry, my b's and betas look the same. Let's write it as b. This would be bj for del x primed of beta by del x j. So these i's and j's are summed over and betas are the same. Okay, now we will multiply this a primed alpha and b primed beta, primed alpha and b primed beta, this turns out to be del x primed alpha over del xi del x primed beta over del xj, and we have ai bj. Now, sorry, this will be bj. Now, this equation, the product of this a primed alpha and b primed beta, is what we define as a tensor, say T, primed of alpha beta. So this is a tensor of rank 2 because there are two index, alpha and beta, is equals to del x primed alpha over del xi del x primed beta over del xj, and this right here, the products of ai bj, is another tensor, say T, having index I and j. So this right here is a tensor transformation equation. Right. So what is this equation telling us? Well, it is telling us that if we have a set of coordinates and then we transform that set of coordinates using a linear transformation matrix, what happens to the products of two vector components? That change is basically represented by this equation. Alright, that is all for today. See you in the next video.